While equations are able to give us plenty of information, sometimes visualizing a problem can help us to see more, literally. In mathematics, our primary way of visualizing an equation is by graphing it. In this video, we will cover the basic vocabulary of graphing and why we use certain elements for certain types of equations. The simplest graph that we use is a number line. Traditionally, single number lines are drawn as a horizontal line with vertical tick marks representing positive values to the right and negative values to the left. We could also have a vertical number line with horizontal tick marks representing increasing values as we move up and decreasing values as we move down. The arrows on either side of the number line show that the line extends infinitely in either direction. We will use number lines to graph the solutions to one-variable equations. If there is a single solution, it will be described by a point on the number line. Points can be open or closed, depending on whether the value is included in the solution or not. If there is a range of solutions, like with inequalities, we may use a line segment stretching between 2 points on the number line, or a ray starting at a single point and stretching into positive or negative infinity, as indicated by the arrow at the end. When we are graphing solutions to two variable equations and functions, we need two number lines, one for each of the variables' values. In order to most effectively graph solutions, we create a grid. The two number lines act as our base. One number line is drawn horizontally, we call this the x-axis. The second number line is drawn vertically, we call this the y-axis. The two number lines intersect where both equal 0. We call this the origin. To make graphing on the plane easier, we extend the tick marks from each number line to create a grid. We call these extended lines grid lines. Grid lines extending from the x-axis will represent x values. Grid lines extending from the y-axis will represent y values. We sometimes refer to these as independent and dependent values. Traditionally, we set up graphs and equations so that y values are written in terms of the x value, making y dependent on the value of x. When we put a point on a grid, we use the intersections of grid lines to show the x and y values simultaneously. Note that we can also put points in the space in between two grid lines to show the in-between values, like fractions and decimals. We label points using ordered pairs, listing the x value first and the y value second. Note that two variable equations show the relationship between x and y values, so there are infinitely many points that could make a two-variable statement true. Instead of graphing every single solution as a point, which would actually be impossible, we use a line to represent all of the values at once. We can graph a line by connecting the points from two or more solutions from one equation, and extending past those points in both directions. When we graph entire lines on a grid, it shows the infinitely many solutions to a two-variable equation. If we are graphing a two-variable inequality, we may shade the grid above or below a line to show all the points in the shaded space are solutions. We can also use a dotted line to show that the line itself is not a part of the solution, just like an open dot shows that a single point is not a part of the solution. Keep in mind that equations will always be drawn with a solid line. When that line crosses the y-axis, we call the point of intersection the y-intercept. When it crosses the x-axis, we call that point of intersection the x-intercept. These points will help us later to determine the solutions and structure in an equation. As we continue to learn about graphs, we will learn how to read them and use them more effectively to tell complex stories. Any activity we participate in has elements that can be graphed, from the passing of time as we speak to the distance traveled by a car and the time it takes to send a text. In this video, we covered the basic principles of graphing and their uses.